Hey Rob, I'm doing problem 7 over. Alright, so this problem 7 reads, suppose that f is a function so that f double prime of x is equal to minus sine of x, and they give you some initial conditions here, f prime of pi is equal to 2, and f of 0 is equal to negative 1. Then with that information, they want us to find f of pi over 2. So let's go ahead and state our initial conditions. So the initial conditions are f prime of pi is equal to 2 and f of 0 is equal to negative 1. Okay, so they give us this f double prime and they want us to find f of pi over 2. But in order to get the function of f of x, the original function f of x, we need to take the antiderivative of this f double prime 2 times. But every time we do the antiderivative, we're going to have a plus c, or a plus d. So for example, the first time I do the antiderivative, I'm going to get f prime, I take the antiderivative, but at the end I have to add a plus, a constant. Now, with this initial condition, I can find that constant. Now again, if I want to find f of x, I've got to take the antiderivative again, and then I'll have another constant I'll call d. With that, to find that constant, I'll use this initial condition. So then I'll find d, and then I'll have my original function f of x, and then we can go ahead and evaluate this. Okay. So let's go ahead and let's write down f double prime of x. That's equal to minus sine of x. Okay, so if I want to go ahead and now let's take the antiderivative. So I take the antiderivative, I'm going to get f prime of x. Okay, so what I want to do now is find a function that if I take the derivative of that function, I get minus sine of x. Well, we know that's cosine of x. Okay, so that's cosine of x plus some constant c. Okay. So now I want to find that constant c. So to find that constant c, I'll have to use this initial condition. So we know that f prime of pi is equal to cosine of pi plus c, and that's equal to 2. Okay, but cosine of pi is negative 1 plus c, and that's equal to 2. Therefore, c is equal to 3. Okay, now that we have c is equal to 3, then f prime of x is now cosine of x plus 3. Alright, but we want f of x. So I need to take the antiderivative of this function to get f of x. So by taking the antiderivative now, again, I get f of x. Now I got to find a function that, if I take the derivative of that function, I get cosine of x. Well, we know that function is sine of x. Now, for this 3, I want to find a function that when I take the derivative of that function, I just get 3. Well, the derivative of 3x is 3, so that's going to be plus 3x. Plus a constant d. Okay, so now I want to find a constant d. But we can use this initial condition to find that constant d. So f of 0 is equal to sine of 0 plus 3 times 0 plus d. Okay, so sine of 0 is 0, so we get 0 plus 3 times 0 is 0. By the way, this d is equal to negative 1. Yes. Then plus d, and that's equal to negative 1. So therefore d is equal to negative 1. Okay, so we have d equal negative 1. So now with d equal negative 1, go back into f of x. Now we have sine of x plus 3x minus 1. Alright, so now we have the function f of x. So now if we have the function f of x, we can go ahead and evaluate f of pi over 2. Okay. So let's go ahead now and evaluate it down here. Alright, so evaluate f of pi over 2. So f of pi over 2 is equal to sine of pi over 2 plus 3 times pi over 2 minus 1. But sine of pi over 2 is 1, and then this one, so let's write this is 1 plus 3 pi over 2 minus 1. So as I was going to say, this 1 minus the 1 will cancel out, and we're just left then with 3 3 pi over 2. Okay, so then that's f of pi over 2 then is 3 pi over 2. So again, if they give us the second derivative and they want us to find f of pi over 2 and they give us some initial conditions, apply the antiderivative, and remember that every time you apply the antiderivative you're going to get a constant c. With that constant c and this initial condition, you can find c. Again, the same thing with d. You'll be able to find d with this initial condition. Once you have your function, just plug in and evaluate.